Legal and ethical disclaimer. This document is for educational and emergency preparedness purposes only. Applicable laws govern all activities. Information on Outage assumes post-disaster, grid down, or humanitarian emergency contexts where conventional sourcing is unavailable. Always prioritize safety. Many procedures involve high-voltage, toxic materials and fire hazards. Improper use can kill. This document does not constitute professional medical, electrical, or engineering advice. Verify all critical information.
This document will be posted under this video, and if any of this information you hear might come in handy to you, or if you're scared of an imminent grid collapse or grid outage, this document might help you out. So, let's get into it. This is just going to be a single cut, so if I mispronounce something, I will just reread it, and I will try my best to lay out all the information that I'm given. I'll be reading from the document on the screen, as well as posting the document below. Section 1. Threat Landscape and Scenario Planning. Understanding your threat environment determines your preparation priorities. Modern worst-case scenarios are often cascading. One failure triggers others. 1.1. Geopolitical. Iran conflict and regional escalation. A U.S.-Iran conflict would likely cause immediate oil price shock. Cyber attacks on infrastructure demonstrates capability against water systems and power grids, and potential maritime disruption of global supply chains. Trigger event, Strait of Hormuz closure. Likely impact, fuel, plus 100 to 400%. Fertilizer shortage. Timeline to fuel, 2 to 4 weeks. Prep priority, fuel storage, food reserves. Trigger event, a cyber attack, on grid/water. Likely impact, regional outages, 2 to 12 weeks. Time to fuel, immediate. Prep priority, water, power backup. Trigger event, sanctions expansion. Likely impact, supply chain disruption, electronics shortage. Timeline to fuel, 1 to 3 months. Prep priority, stockpile key parts/tech. Trigger event, regional war escalation. Likely impact, oil embargo, military mobilization. Timeline to fuel, months. Prep priority, long-term food, barter goods. Trigger event, domestic social disruption. Likely impact, store runs, civil unrest. Timeline to fuel, days after trigger event. Prep priority, security, community networks. 1.2. Energy crisis and grid failure. The U.S. grid is 3 separate interconnections: Eastern, Western, Texas. A significant physical or cyber attack on a few as 9 voltage transformer subdivisions could cause a cascading failure. Lead time to replace large transformers, 12 to 18 months. Most transformers are not manufactured domestically. Grid failure type, rolling blackouts. Duration, hours, days. Primary effect, device disruption, food spoilage. Secondary effect, medical device failure. Grid failure type, regional grid collapse. Duration, weeks to months. Primary effect, water pump failure, fuel unavailable. Secondary effect, societal breakdown risk. Grid failure type, EMP, nuclear, solar. Duration, months to years. Primary effect, all electronics destroyed. Secondary effect, full infrastructure collapse. Grid failure type, cyber attack targeted. Duration, days to weeks. Primary effect, SCADA systems compromised. Secondary effect, industrial accidents. Grid failure type, extreme weather event. Duration, days to weeks. Primary effect, localized outage, road closures. Secondary effect, supply chain freeze. 1.3 Isolationism and supply chain collapse. Extreme isolationist policy or global trade war halts imports of pharmaceuticals, 80% generic drugs from India/China, electronics, rare earth minerals, and food staples. Long-form shortages become normalized within 90 days. Commodity, semiconductors, advanced. U.S. import dependence, 90% fabrication capacity offshore. Crisis timeline, immediate on devices. Alternatives, repair or salvage old hardware. Commodity, generic pharmaceuticals, U.S. import dependence, 80% from India/China. Crisis timeline, 60 to 90 days. Alternatives, herbal, stockpile, veterinary. Commodity, fertilizers, potash, and phosphate. U.S. import dependence, 50% imported. Crisis timeline, 1 to 2 growing seasons. Alternatives, composting, manure, and ash. Commodity, rare earth magnets. U.S. import dependence, greater than 90% from China. Crisis timeline, 3 to 6 months on motors/EVs. Alternatives, salvage from e-waste. Commodity, petroleum products. U.S. import dependence, partially domestic. Crisis timeline, immediate price shock. Alternatives, biodiesel, ethanol, wood gas. Section 2, water extraction, purification, and storage. Water is the single highest priority survival resource. A human needs a minimum of 0.5 liters a day to survive, 2 liters a day to function, 4+ liters a day for hygiene, cooking, and medical needs. 2.1 Atmosphere water generation. Dehumidifier method. A dehumidifier extracts moisture from air by cooling it below the dew point. This is your fastest reliable water source indoors or in humid climates. Salvaging/repurposing a dehumidifier. Standard residential dehumidifiers use a refrigerant compressor, R410A or R32, evaporation coil, condenser coil, and fan. They require AC power, 300 to 800 watt typical. They produce 20 to 70 pints per day, depending on humidity. Component, compressor. Function, pumps refrigerant, creates cold surface. Salvage source, window AC, refrigerator, dehumidifier. Notes, R410A at 150 to 600 psi do not puncture. Component, evaporator coil. Function, cold surface, air moisture condenses here. Salvage source, same as compressor. Notes, must be from matching refrigerant system. Component, fan motor. Function, pulls humid air across coil. Salvage source, any AC, furnace blower. Notes, 12 volt or 24 volt DC fans from auto salvage work with inverter. Component, water collection tray. Function, collects condensate. Salvage source, any food safe container. Notes, must be clean. Condensate is near pure H2O. Component, control board. Function, Thermostat/humidity sensing. Salvage source, optimal. Salvage source, optional, can be hardwired. Notes, bypass with manual switch if failed. Dehumidifier water quality. Condensate from a clean coil is distilled equivalent, very pure, 0 TDS, total dissolved solids. However, if coils are dirty or unit has mold, it can harbor Legionella, mold spores, and particulates. Always run condensate through carbon filter or boil before drinking. A simple activated charcoal filter, salvage aquarium carbon, is sufficient. Water yield formula, RH% and temp determine output. At 80 degrees Fahrenheit, 70% RH, a 500 watt unit produces 35 pints a day, 16.5 liters. At 50% RH, the same unit produces 15 pints per day, below 40%. The same unit produces 15 pints per day. Below 40% RH, output drops dramatically. In dry climates, dew collection or solar still is more practical. Powering a dehumidifier off-grid. Most dehumidifiers require 110 volt AC at 300 to 800 watt. Options: pure sine wave inverter, see section 3, connected to a battery bank. Minimum 100 amp hours, 12 volt for 1 hour, 500 watt load. A 500 watt unit for 8 hours equals 4 kilowatt hours, requires 333 amp hours at 12 volt, accounting for inverter losses. Thermoelectric Peltier dehumidifiers exist and run on 12 volt DC directly. Only 20 to 40 watts, but 1 to 2 liters a day in humid conditions. DIY Peltier unit. TEC1/12706 model. 12 volt 6 amp max aluminum heatsink PC fan. Cost $10 to $15 if parts are salvaged. 2.2 Solar still. Arid climate water extraction. A solar still requires only clear plastic sheeting, a digging tool, and a container. It extracts water from soil, vegetation, or urine through solar-powered evaporation and condensation. Parameter: pint size optimal. Value: 3 feet by 3 feet, 2 feet deep. Notes: larger surface equal more yield. Parameter: plastic sheet. Value: 4 to 6 mil clear polyethylene. Notes: salvage from construction site, greenhouse, storage bags. Parameter: daily yield 0.5 to 1 liter a day. 1 to 3 liters moist soil. Notes: vegetation inside boosts yield significantly. Parameter: collection container. Value: any food-safe bowl/bucket at a center. Notes: drinking straw through plastic avoids disrupting still. Parameter: time to first water. Value: 1 to 2 hours of full sun. Notes: best output 10 a.m. to 3 p.m. Parameter: temperature pit floor. Value: target 120 to 140 degrees Fahrenheit. Notes: use dark material on pit floor to absorb heat. Water filtration and purification. Ratios and methods. Never drink untreated water from unknown sources. Use multiple stages for maximum safety. Method: boiling. 1 minute rolling, 3 minute at altitude. Removes all pathogens, bacteria, virus, protozoa. Do not remove heavy metals. It does not remove heavy metals, chemicals, and sediment. Notes: most reliable biological treatment, costs only fuel. Method: chlorine, unscented bleach, 5 to 8.25%. Removes bacteria, most viruses. Does not remove crypto, giardia partially, and chemicals. Notes: 2 drops per liter clear water, 4 drops per liter cloudy water. Wait 30 minutes. Method: iodine tablets. Removes bacteria, viruses. Does not remove Critosporidium. Notes: 8 milligrams per liter, less effective in cold/turbid water. Method: activated carbon filter. Removes chemicals, chlorine, odors, particulates. Does not remove pathogens. Note: salvage from Brita aquarium or make from hardwood char. Method: DIY biosand filter. Removes bacteria 90 to 99%. Sediment, protozoa. Does not remove viruses, dissolved chemicals. Notes: layers: gravel, coarse, sand, fine sand. 1 to 2 inch biolayer. UV removes all pathogens if sufficiently dosed. Does not remove sediment chemicals. Must pre-filter for that. Notes: SODIS 6 hour in clear PET bottle in direct sun is effective. Critical ratio. Bleach 5 to 8.25% sodium hypochlorite, 2 drops per liter of clear water, 4 drops per liter of turbid/cold water, 1 to 1/4 teaspoon per gallon for large batch. Contact time 30 minutes minimum before drinking. 2.4 Rainwater collection and storage. A 1,000 square foot roof catches approximately 620 gallons per inch of rainfall. First, flush the diverter. Discard the first 10 gallons. Removes most contamination. Store in food grade containers, dark colored to prevent algae. Container type: 55 gallon food grade drum HD PE. Capacity: 55 gallons, 208 liters. Salvage notes: from food/beverage distribution. Car wash. Lifespan: 20 years if UV protected. Container type: IBC tote. Capacity: 264 gallons, 1,000 liters. Salvage notes: industrial, farm supply, food processing, blue/white. Lifespan: use within 4 weeks, treat with bleach. 15 plus years if opaque. Container type: swimming pool, emergency. Capacity: 10,000 to 30,000 gallons. Salvage notes: existing asset, water BOB liner for bathtub, 100 gallon. Lifespan: use within 4 weeks, treat with bleach. Container type: underground cistern. Capacity: 500 to 5,000 gallons. Salvage notes: concrete septic tank, repurposed, clean first. Permanent lifespan is permanent if sealed. Container type: garbage can emergency. Capacity: 32 to 96 gallons. Salvage notes: immediate use, food grade preferred. Lifespan: 1 to 3 years. Section 3: Power, inverters, solar, battery banks, and fuel. Electricity enables everything else: water pumping, communication, refrigeration, lighting, medical devices, and information access. Understanding power math is essential. Section 3.1: Power Fundamentals. The math you must know. Ohm's law and power calculations are the foundation. Every watt you produce costs stored energy. Every watt you waste is water, food, or communication you may not have. Formula: watts equals volts times amps. Use case: calculate power draw. Example: 12 volts times 20 amps equals 240 watts. Formula: watts hours equal watts times hours. Use case: calculate energy needed. Example: 100 watt for 5 hour equals 500 watt hours. Formula: capacity, amp hour capacity, EV, watt hours / voltage. Use case: size your battery bank. Example: 500 watt hours by 12 volts equals 41.7 amp hours. Inverter efficiency: P underscore out over P underscore in. Account your inverter losses. Example: 500 watt load over 0.85 efficiency equals 588 watt draw from battery. Formula: solar calculation. Watt hour over sun hours times 0.75. Use case: size solar panel array. Example: 1000 watt hours over 5 hours times 0.75 equals 267 watt of panels needed. Formula: battery usable capacity, lead acid. Use case: only use 50% of rated amp hour to preserve lifespan. Example: 200 amp hour battery equals 100 amp hour usable. Formula: battery usable capacity, lithium iron phosphate. Use case: use 80 to 90% of rated amp hour safely. Example: 100 amp hour lithium iron phosphate equals 80 to 90 amp hour usable. Section 3.2: Inverters. Types, selection, and salvage. An inverter converts DC battery power to AC power, 110 volt to 220 volt. Not all inverters are equal. The type matters enormously for what you can run. Type: modified sine wave, MSW. Output wave: stepped approximation of sine. Suitable for simple resistive loads, lights, fans, drills. Avoid: for medical devices, sensitive electronics, AC motors, dehumidifiers. Type: pure sine wave, PSW. Output wave: true sine wave identical to grid. Suitable for everything including motors, medical, chargers. Avoid for nothing. It runs all loads safely. Type: grid tie inverter. Output wave: must sync to grid, not standalone. Suitable for grid connected solar only. Avoid for off-grid use. Will not work without grid. Type: hybrid / off-grid inverter. Output wave: pure sine plus battery management plus MPPT. Suitable for complete solar systems. Avoid for simple backup use, overkill, and expensive. Salvage rule: always use a pure sine wave inverter for dehumidifiers, well pumps, refrigerators, and any device with a motor or sensitive electronics. Modified sine wave will damage or destroy these devices over time. Wiring an inverter to a battery bank. Safety and wire sizing are critical. Undersized wires will cause a fire. Oversized fuses will cause fire. Follow these specifications. Inverter size: 300 watt. Max current draw: 12 volt, 30 amp. Minimum wire gauge: 10. Fuse size: 40 amp. Max wire length, each side 3 feet. Inverter size, 500 watt. Max current draw, 12 volt, 50 amp. Minimum wire gauge, 8. Fuse size, 60. Max wire length, each side 3 feet. Inverter type, 1000 watt. Max current draw, 12 volt, 100 amp. Minimum wire gauge, 4. Fuse size, 125 amp. Max wire length each side, 3 feet. Inverter size, 1500 watt. Max current draw, 12 volt, 150 amp. Minimum wire gauge, 2. Fuse size, 175 amp. Max wire length each side, 2 feet. Inverter size, 2000 watt. Max current draw, 12 volt, 200 amp. Minimum wire gauge, 2/0. Fuse size, 250 amp. Max wire length each side, 2 feet. Inverter size, 3000 watt. Max current draw, 12 volt, 300 amp. Minimum wire gauge, 4/0. Fuse size, 400 amp. Max wire length each side, 18 inches. Installation steps. Inverter to battery. Mount inverter as close to the battery pack as close to the battery bank as possible. Voltage drop increases with wire length. Install fuse or circuit breaker within 18 inches of battery positive terminal. Connect negative black wire first, then positive red. Prevent spark nearby battery. Use ring terminals crimped and soldered for each connection. Vibration causes resistance over time. Verify no voltage drop at inverter terminals under load. Should not exceed 0.5 volt drop. Measure with multimeter. Ground inverter chassis to battery negative. Prevents static buildup and ground fault shock. Solar panels, salvage, setup, and sizing. Section 3.3. Photovoltaic panels generate DC electricity from sunlight. A salvaged panel from damaged array is often 80 to 95% functional. Small cracks in cells reduce output but don't eliminate it. Panel type: monocrystalline, black. Efficiency: 19 to 22%. Salvage/ID notes: uniform black cells, premium product. Typical VMP: 30 volt for 60 cells. Typical IMP: 8 to 10 amp. Panel type: polycrystalline, blue. Efficiency: 15 to 18%. Salvage/ID notes: blue speckled cells, older/cheaper. Typical VMP: 29 volt. Typical IMP: 7 to 9 amp. Panel type: thin film, flexible/black. Efficiency: 10 to 13%. Salvage/ID notes: flexible or glass laminated, low profile. Typical VMP varies. Typical IMP low. Salvage/damaged panels: efficiency 50 to 90% of rated. Salvage of ID notes. Test VOC and ISC with multimeter. Typical VMP, test actual. Typical IMP, test actual. Testing a salvaged panel. In direct sunlight, measure VOC, open circuit voltage, and ISC, short circuit current, with a multimeter. VOC should be within 10% of the label. ISC should be within 20% of the label. Significant deviation indicates cell damage. Charge controllers, MPPT versus PWM. Never connect solar panels directly to a battery. You need a charge controller to prevent overcharging and match panel voltage to battery voltage. Type, PWM, pulse width modulation. Efficiency, 70 to 80%. Use when panel VMP is close to battery voltage. Example, 18 volt panel to 12 volt battery. Cost, low, $15 to $40. Type, MPPT, maximum power point tracking. Efficiency, 93 to 98%. Use when higher voltage panels, 30 plus volt, to lower voltage battery for maximum yield. Cost, medium, $30 to $150. Critical. A 30 volt panel to a 12 volt battery bank requires MPPT. PWM will waste 40% of your power and cause damaged panels over time. Section 3.4, Battery Banks. Chemistry, Sizing, and Building. Chemistry. Lead acid, flooded. Cycle life, 300 to 500. DOD, 50%. Weight per kilowatt hour, 25 to 30 kg. Cold tolerance, poor, freezes if discharged. Safety, vent H2 gas, moderate. Salvage, high. Chemistry, AGM lead acid. Cycle life, 400 to 700. DOD, 50 to 60%. Weight per kilowatt hour, 25 kg. Cold tolerance, better than flooded. Safety, sealed, good. Salvage, high. Chemistry, lithium iron phosphate. Cycle life, 2,000 to 5,000. DOD, 80 to 90%. Weight per kilowatt hour, 5 to 8 kilograms. Cold tolerance, reduced capacity below 32F. Safety, very safe, no thermal runaway. Salvage, medium. Chemistry, lithium ion, salvaged laptop/tool batteries. Cycle life, 200 to 500. DOD, 70%. Weight per kilowatt hour, 3 to 5 kg. Cold tolerance, moderate. Safety, fire risk if damaged, caution. Salvage, high. Building a 12 volt lead acid battery bank from car batteries. Car batteries, starting batteries, are not ideal for deep cycle use but are universally available and salvageable. Reserve capacity RC and cold cranking amps CCA are labeled. For deep cycle use, look for deep cycle marine batteries. Connecting in parallel, same voltage, additive AH, amp hours. Connect all positive terminals together, all negative terminals together. 4x 100 amp hour batteries equals 400 amp hours at 12 volts. Connecting in series, additive voltage at same amp hour. Positive of battery 1 to negative of battery 2. Example, 2x 12 volt equals 24 volt system. 4x 6 volt golf cart batteries equal 24 volts. Always use batteries of same age, chemistry, and charge state when combining in banks. Use 4/0 welding cable, not automotive wire, for connections. It stays flexible in cold and handles the current. Section 3.5, Alternative Power Sources. Source, gasoline generator. Power output 1 to 10 kilowatts. Fuel reserve, gasoline. Runtime 6 to 8 hours. Notes, Store fuel with pre-G stabilizer. Shelf life 1 to 2 years treated. Source: propane generator. Power output 1 to 10 kilowatts. Fuel reserve: propane LP. Runtime: long tank life. Notes: propane stores indefinitely. Preferred for long term. Source: dual fuel generator. Power output 1 to 8 kilowatt. Fuel reserve: fuel/resource, gas or propane. Runtime: flexible. Notes: most versatile. Switches fuels as available. Source: wood gasifier, DIY. 2 to 10 power output is 2 to 10 kilowatts equivalent. Fuel/resource, dry wood/biomass. Runtime: continuous fed. Notes: complex build. Source: wind turbine, small. Power output 0.5 to 3 kilowatts. Fuel resource, wind. Runtime: when wind is greater than 7 miles per hour. Notes: salvage from farm wind chargers, 12 volt/24 volt output. Source: bicycle generator. Power output 50 to 150 watt sustained. Fuel/resource, human power. Runtime: continuous. Notes: efficient for phone/radio charging, not for major loads. Source: vehicle alternator, running. Power output 50 to 150 amp at 12 to 14 volt. Fuel/resource, engine fuel. Runtime: while running. Notes: run car 30 minutes equals 30 to 40 amp hours into battery bank. Biodiesel emergency production. Biodiesel can be made from waste cooking oil and is a direct diesel substitute. Basic transesterification reaction. Vegetable oil plus methanol plus lye, sodium hydroxide. Biodiesel and glycerol are the products. Component: waste vegetable oil, waste/cooking oil. Ratio: per liter of oil, 1 liter, 100 grams. Source: restaurant fryers, food processing. Notes: filter out food particles. Water ruins the reaction. Component: methanol, 99% pure. Ratio per liter of oil, 200 milliliters, 20%. Source: hardware store solvent, HEET, yellow bottle. Notes: highly flammable, no open flame. Store separately. Component: sodium hydroxide, lye. Ratio per liter of oil, 3.5 to 7 grams. Titrate to oil quality. Source: drain cleaner, 100% sodium hydroxide, Red Devil brand. Note: titrate WVO. Dissolve 1 gram sodium hydroxide in 1 liter water. Add phenolphthalein. Titrate with WVO. Milliliters used equals grams extra lye needed. Component: temperature. Ratio per liter of oil, 130 to 140 degrees Fahrenheit. Source: heat source. Notes: keep constant during reaction. Too hot degrades product. Component: reaction time. Ratio per liter of oil, 1 hour stirring. Source: manual or mechanical. Notes: glycerol separates and sinks within 8 to 12 hours. Dark layer on bottom. Biodiesel safety. Caution. Methanol is highly toxic, absorbs through skin, causes blindness and death. Use gloves, goggles, and outdoor only. Lye, sodium hydroxide, causes severe chemical burns. Mix lye into methanol slowly, never reverse. Never mix lye and water. Exothermic gets extremely hot. Mix lye and methanol instead. Never use an open flame near the process. Use electrical hot plates only. Wash finished biodiesel with water 3 to 4 times to remove soap and methanol before use in engine. Section 4. Food, production, preservation, and nutrition. Caloric minimums and nutritional requirements. Population: adult, male, sedentary. Minimum calories per day: 1,500. Optimal calories a day: 2,000 to 2,500. Protein per grams per day: 56 grams. Fat grams a day: 55 grams. Adult male, heavy labor. Minimum calories a day: 2,500. Optimal calories a day: 3,500 plus. Protein: 100 grams. Fat: 90. Adult female, sedentary. 1,200 calories a day. Optimal calories a day: 1,600 to 2,000. Protein: 46 grams. Fat: 44 grams. Child: 5 to 10. Minimum calories a day: 12,000. Optimal calories a day: 1,400 to 1,600. Protein: 25 to 35 grams. Fat: 35 grams. Elderly, 65 plus. Minimum calories a day: 1,400. Optimal calories a day: 1,800. Protein per day: 60 grams. Fat per day: 50 grams. 4.2 Long-term food storage. Caloric density and shelf life. Food: white rice. Calories per 100 grams dry: 365. Shelf life: 25 to 30 years. Sealed O2 absorber. Water needed to cook: 2 to 1 water to rice ratio. Storage notes: brown rice only 6 months. Oils go rancid. Food: hard red wheat berries. Calories a day: 340. Calories per 100 grams dry: 340. Shelf life: 30 plus years if sealed. Water needed to cook. Grind before use. Storage notes: need hand grain mill, extremely versatile. Food: pinto/black beans. Calories per 100 grams dry: 347. Shelf life: 25 to 30 years. Water needed to cook: 3 to 1 water to beans. Storage notes: pair with grains for complete protein. Food: white flour sealed. Calories per 100 grams dry: 364. Shelf life sealed: 5 to 10 years. Water needed to cook: variable. Storage notes: less stable than whole berries. Food: rolled oats. Calories per 100 grams dry: 389. Shelf life: 30 years and O2 free, sealed. Water needed to cook: 2 to 1 water to oats. Storage notes: high caloric density, good fat content. Food: honey, raw. Calories per 100 grams dry: 304. Shelf life: indefinite. Water needed to cook: none. Storage notes: antimicrobial, wound dressing, sweetener. Food, salt, non-ionized. Calories per 100 grams dry, 0. Essential mineral. Shelf life, sealed, indefinite. Water needed to cook, none. Storage notes, electrolyte, food preservation, store heavily. Food, sugar / white or brown. Calories per 100 grams dry, 387. Shelf life, sealed, indefinite if dry. Water needed to cook, none. Storage notes, fermentation, feedstock, preservation. Food, canned goods, varies on 100 calories dry. Shelf life, 5 to 7 years, some 25 plus years. Water needed to cook, minimal, ready to eat. Storage notes, FIFO rotation. Note botulism risk indents. Food, freeze-dried meals. 100 grams dry, varies. Shelf life, 25 years if sealed. Water needed to cook, varies. Storage notes, best quality / shelf life, expensive. Food, cooking oil, coconut. Calories per 100 grams dry, 884. Shelf life, 2 years. Water needed to cook, none. Notes, highest calorie per gram of any food. Prioritize storage. Pemmican, food. Calories per 100 grams dry, 490 to 700. Shelf life, 1 to 5 years. Water needed to cook, none. Notes, fat plus dried meat. Travel food, extremely dense. Section 4.3, food preservation without refrigeration. Salt curing. Salt draws moisture out of food through osmosis, creating an inhospitable environment for bacteria. 2 methods. Dry cure. Use 2.5 to 3% salt by weight for short cure, 2 to 3 days / inch of thickness. Use 5 to 7% for long term. Mix with 0.25 pink curing salt, sodium nitrate, to prevent botulism in thick cuts. Brine cure. 10 to 15% salt solution. 100 to 150 grams salt per liter of water. Fully submerge the meat. 1 to 2 weeks for full penetration of thick cuts. 3 to 4 days for fish. Prague powder number 1, pink salt. 6.25% sodium nitrate. Use 1 teaspoon, 5.6 grams per 5 pounds of meat / cured smoked products. Critical. This prevents botulism in anaerobic environments. Dehydration. Food, meat, jerky. Target moisture, less than 10%. Time, at 145 degrees Fahrenheit, 63 degrees Celsius, 4 to 8 hours. Complete test, bends without cracking, no moisture. Shelf life, 1 to 2 months ambient, 1 year vacuum sealed. Food, vegetables. Target moisture, less than 10%. Time at 145 F, 6 to 12 hours. Completed test, crisp, break apart. Shelf life, 1 to 2 years sealed. Food, fruit. Target moisture, less than 15%. Time at 145 F, 8 to 16 hours. Completed test, leathery, not sticky. Shelf life, 6 to 12 months. Food, herbs. Target moisture, less than 5%. Time at 145, 2 to 4 hours. Completion test, crumbles easily. Shelf life, 2 to 3 years. Food, eggs, scrambled first. Target moisture, less than 5%. Time at 145F, 8 to 12 hours. Completion test, powder or dry flake. Shelf life, 2 to 5 years, vacuum sealed. Fermentation, no equipment needed. Fermentation is one of the most powerful food preservation methods and can increase nutrition, while lacto fermentation requires only salt and vegetables. Wild lacto fermentation requires only salt and vegetables. Basic ratio, 2 to 3% salt by weight of vegetables. 1 teaspoon salt per pound of vegetables is a common approximation. Pack vegetables tightly in jar. Salt draws brine naturally. Keep vegetables submerged below brine to prevent mold. Temperature, 65 to 75 Fahrenheit. Optimal. Fermentation time, 3 to 7 days for quick, 4 to 6 weeks for full lacto fermented sauerkraut/kimchi. Signs of success: bubbling CO2, sour smell, tangy taste. Signs of failure: pink/black mold on top. Scrape surface mold off and discard. Vegetable below is usually still fine if brine is sour. Section 4.2, Emergency Garden, High Yield, Fast Crops. Crop, radishes. Days to harvest, 25 to 30 days. Calories per square feet per year. Low, eat greens too. Space needed, dense planting. Soil requirements, any, very forgiving. Crop, lettuce/greens. Days to harvest, 30 to 45 days. Calories per square foot, medium. Space needed, 4 inches apart. Moderate fertility are soil requirements. Crop, beans, pole. Days to harvest, 50 to 65. Calories per square foot, high, protein plus calories. Space needed, 1 square feet per plant. Soil requirements, good drainage, nitrogen fixing. Crop, sweet potatoes, 100 to 120 days. Calories per square foot, 450. Space needed, wide spacing, 12 to 18 inches. Soil requirements, sandy, well drained. Crop, squash, winter. Days to harvest, 80 to 100. Calories per square foot, high. Space needed, 10 square feet per plant. Soil requirements, rich soil. Crop, corn, field. Days to harvest, 80 to 100. Calories per square foot, very high. Starch. Space needed, 12-inch apart, block plant. Soil requirements, rich, dry water. Rich, well watered, Crop, amaranth. Days to harvest, 50 to 60. Days green, 90 to 120. Grain. Calories per square foot, very high, complete protein. Space needed, 18 inches apart. Soil requirements, any, drought tolerant. Crop, potatoes. Days to harvest, 70 to 120. Calories per square foot, high, 400 calories per square foot. Space needed, 12 inches apart, hills. Soil requirements, loose, fertile soil. Section 5, Shelter, Thermal Management, and Medical. Heating without grid power, Section 5.1. Hypothermia begins when core body temperature drops below 95 F, 35 degrees Celsius. Prevention and shelter are always more efficient than treatment. Heat source: wood stove, cast iron. BTU output: 20,000 to 100,000. Fuel efficiency: high, 80% efficiency. Indoor safety: yes, with proper flue. Salvage notes: salvage from demolished homes. Check for cracks. Heat source: rocket mass heater, DIY. BTU output: 90% efficiency. Fuel efficiency: very high, 1/4 wood of conventional. Indoor safety: yes, requires expertise. Salvage notes: build from fire brick, pipe, clay, YouTube plans. Heat source: propane heater. BTU output: 9,000 to 18,000. Fuel efficiency: moderate. Indoor safety: indoor rated, models only, crack window. Salvage notes: portable, 1 pound canister equals 2 hours at height. Heat source: kerosene heater. BTU output: 8,000 to 23,000. Fuel efficiency: moderate. Indoor safety: some CO risk. Ventilate. Salvage notes: use number 1 kerosene, K1, store in metal container. Heat stove, hot water bottles. Heat source, hot water bottles. BTU output: body safe. Fuel efficiency: very low fuel use. Indoor safety: yes, completely safe. Salvage notes: recycle plastic bottles. Fill before bed for sleeping. Passive heating, the thermal layer system. Layer 1, base, wool or synthetic, not cotton, kills when wet. Polypropylene underwear, best for moisture wicking. Layer 2, mid, fleece or wool sweater, traps air equals insulation. Layer 3, outer, windproof/waterproof shell, stops convective heat loss. Critical zones: head, 40% heat loss. Neck, wrists, feet. Insulate these first. Sleeping bag, plus wool blanket inside of an enclosed small space with body heat from multiple people is the simplest survival heating. A 10 by 10 foot room heated by 3 bodies generates approximately 1,000 BTU an hour, enough to maintain 45 to 55 degrees Fahrenheit in moderate insulation. 5.2 Cooling without air conditioning. Heat stroke begins at core temperatures above 104 Fahrenheit, 40 degrees Celsius. Wet bulb temperature above 88 Fahrenheit, 31 Celsius is dangerous for prolonged outdoor exposure. The human body can no longer effectively cool itself at wet bulb temps above 95 degrees Fahrenheit. Evaporative cooling. Wet thin fabric, cotton works, drape over the body in moving air, effective in low humidity, greater than 50%, less than 50%. Can reduce perceived temperature by 10 to 20 degrees Fahrenheit. DIY swamp cooler. A 12-volt fan blowing through wet burlap or cooling pad. Add ice water, spray for enhancement. Draws only 20 to 50 watt. Works well under 50% RH. Radiant shielding. Aluminum foil/emergency blanket on south and west windows block 90% of radiant heat gain. This alone can reduce room temperature 10 to 15 degrees Fahrenheit. Night flush cooling. Open all windows at night to cool thermal mass, walls, floors. Close and seal at sunrise. Works best in climates with 20 plus Fahrenheit day/night differential. Underground shielding. Earth temperature 6+ feet down is approximately the annual mean air temperature, 55 to 65 F in most of the US. Basements, root cellars, and caves are natural heat refuges. Section 5.3, Medical Essentials. Critical without hospital access. Medical disclaimer. The following is for emergency use only when professional medical care is genuinely unavailable. Improvised medical care carries serious risks. These are last resort references, not a substitute for training. Obtain Wilderness First Aid WFA or Wilderness First Aid Responder WFR training. These are critical survival skills. Item/skill. Betadine. Providone iodine 10%. Function wound antiseptic. Dosing/notes dilute to 1% for wound irrigation, 1 to 9 water. Alternatives if unavailable: saltwater flush, honey dressing. Item/skill. Silver, colloidal or gauze. Function: antimicrobial, wound dressing. Dosing/notes: apply dressing or gauze to wound. Alternative if unavailable: honey, raw, manuka, proven antimicrobial. Item/skill. Activated charcoal. Function: oil poisoning. Absorbs toxins. Dosing/notes: 1 gram per kg body weight in water. Give within 1 hour of ingestion. Alternatives if unavailable: induced vomiting. Some cases only, not caustics/acids. Item/skill. Quick clot. Hemostatic gauze. Function: stop severe bleeding. Dosing/notes: pack wound firmly. Maintain pressure 3 to 5 minutes. Alternatives if unavailable: improvised. Chitosan from shrimp cells. Dry cornstarch, packed. Item/skill. Oil rehydration salts, ORS. Function: dehydration/diarrhea. Most common killer. Dosing notes: HWO formula. 1 liter of water plus 6 tablespoons sugar plus 5.5 tablespoons salt. Alternatives if unavailable: coconut water, broth with salt. Item/skill. Antibiotics. Fish/veterinary. Function: bacterial infection. Dosing: amoxicillin 500 milligrams TID. Dosing/notes: doxycycline 100 milligrams BID. Alternatives if unavailable: critical. Known indication: antibiotic overuse causes resistance. Item/skill. Dental kit. Temporary filling. Function: broken tooth/lost crown pain. Dosing notes: zinc oxide, eugenol paste, or sugarless gum temporary. Alternatives if unavailable: clove oil. For pain, apply to socket. Item/skill. SAM splint. Function: fracture immobilization. Dosing/notes: pad well, immobilize joint above and below fracture. Alternatives if unavailable: improvise from rigid branch plus cloth binding. Sutures versus wound closure. Priority guide. Do not close infected wounds. Clean, irrigate, pack open, allow drainage. Close wounds. Face/cosmetic areas within 6 to 8 hours. Other areas within 6 hours. Use steri strips, butterfly closures, before sutures when possible. Irrigation is 10 times more important than closure. Use a 20 ml syringe with 80 gram needle. Creates 8 psi irrigation pressure. Use 200 to 500 milliliters of clean saline or water per wound. Wound closure guide. Dermabond superglue. Effective for small clean lacerations. Apply to skin surface only. Do not inside of wound. Section 6. Communication, offline AI, and information systems. Information is power in a crisis. Communication enables coordination, intelligence, and access to this knowledge. Offline AI, digital libraries preserve expertise without internet access. Radio communication systems 6.1 type GMRS/FRS walkie-talkie, range 1 to 5 miles, line of sight. License required. GMRS needs FCC license. Power draw, battery 0.5 to 5 watt, best for local team communication. Type ham radio HF, 40M/80M band. Range regional to global via ionosphere. License required. Technician/Genera I license. Power draw 5 to 100 watts. Best for long distance news gathering. Type ham radio VHF/UHF 2M/70cm. Range 5 to 150 miles with repeater. License required. Technician license. Power draw 5 to 50 watts. Best for regional network emergency nets. Type CB radio 27 MHz. Range 5 to 20 miles mobile. License required. No license. Power draw 4 watt max. Best for trucker/vehicle coordination. Public use. Type low raw 915 megahertz digital. Range 5 to 50 miles with antenna. License required. No license. Power draw 0.1 to 1 watt. Best for low power data/mesh network. Type shortwave receiver. No TX. Range global reception. None. License required. Power draw 0.5 to 2 watt. Receive BBC, VOA, international news. Type satellite Garmin InReach Starlink. Range global. License required. Subscription. Power draw moderate. Low. Best for last resort messaging internet. 6.2 Offline AI, running language models without internet. Large language models can be run locally on a laptop or dedicated device, providing access to medical, technical, engineering, and scientific knowledge without internet. This requires setup before a crisis. Model/tool. Llama 3.2 3B 8B. Hardware needed 4 to 8 gigabytes RAM, CPU only. Size 2 to 5 gigabyte download. Capability general Q&A. Instructions writing. Setup olama.com. 1 command install. Mode/tool. Mistral 7B. Hardware needed 8 gigabyte RAM minimum. Size 4 to 5 gigabytes. Capability excellent reasoning. Instructions. Setup Olama or LM Studio. Model/tool Pi 3 Mini Microsoft. Hardware needed 4 gigabytes of RAM. Size 2.3 gigabytes. Capability medical Q&A. STEM good for limited hardware. Olama setup. Model/tool Gemma 2 2B. Hardware needed 8 gigabytes of RAM. Size 1.5 gigabytes. Capability fast, lightweight, good general knowledge. Setup Olama. Mode/tool Med Llama/Med Alpaca. Hardware needed 8 gigabytes of RAM. Size 2 to 7 gigabytes. Capability medical diagnosis support, drug info. Setup: Hugging Face download plus llama.cpp. Model tool: Kiwix plus Wikipedia offline. Hardware needed: 16 gigabytes of storage. Height, size, full Wikipedia equals 85 gigabyte compressed. Capability: full Wikipedia plus medical reference. Setup: kiwix.org, free download, offline reader. Setting up offline AI before crisis. Install olama.com, runs on Windows, Mac, Linux. One-click install. Run olama poll llama 3.2 in terminal. Downloads model to your device. Run olama serve, then access via browser http://localhost 11413. Download OpenWeb UI, GitHub for ChatGPT-like interface that works fully offline. Also, download Kiwix and the offline Wikipedia medical and reference packages. Store everything on 512 gigabyte, 1 terabyte USB drive as backup. A Raspberry Pi 4 8 gigabyte can run Pi 3 Mini and serve the whole household via local Wi-Fi with no internet needed. Raspberry Pi Power Draw 5 watts runs all day on small solar plus battery system. Raspberry Pi as offline server. Specifications setup. Use case: offline AI, small model, Pi 4, 8 gigabytes, Pi 5. Storage needed: 64 gigabytes plus micro SD or SSD. Power: 5 to 15 watts. Software: Olama plus OpenWeb UI. Use case: offline Wikipedia/library. Pi model: Pi 4, 4 plus gigabytes. Storage needed: 128 gigabytes, 1 terabyte USB drive. Power: 5 to 10 watts. Software: Kiwix server. Use case: mesh network node. Pi model: Pi 0, 2 watt or Pi 4. Storage needed: 16 gigabytes micro SD. Power: 1 to 5 watt. Software: Mesh-tastic, Batman/ADV or Reticulum. Use case: weather station. Pi 0 or Pi 4. Storage needed: 16 gigabytes. Power: 1 to 5 watt. Software: WX BME 280 sensor, $3. Use case: radio gateway ham, Pi 4. Storage needed: 32 gigabytes. Power: 5 to 15 watts. Software: Direwolf AX.25 packet, JS8 call. 6.4 Mesh networks. Community communication without internet. A mesh network allows a community to communicate digitally without any internet connection or central infrastructure. Nodes relay messages between each other, self-healing around failures. Mesh static, LoRa based, 30 to 50 hardware. Deltec or Lily Got beam boards range 5 to 15 miles per HOP. Text messages, GPS location encrypted, battery powered for days. Works on 915 megahertz US unlicensed spectrum. GoTenna Mesh, commercial, encrypted mesh, $100 per device. Works in areas with dense user deployment. Arden, amateur radio emergency data network. Ham radio based, high bandwidth Wi-Fi speeds, requires ham license, range 5 to 40 miles per node. Enterprise grade mesh for coordinated centers. Reticulum network stack. Software defined cryptographic network. Runs over LoRa, packet radio, Ethernet, Wi-Fi. fully decentralized, run on Raspberry Pi. Section 7. EMP, EMF, shielding, and Faraday protection. An electromagnetic pulse, EMP, whether from a nuclear detonation at altitude, a coronal masses injection, Carrington level event, or a non-nuclear EMP device, can destroy unprotected electronics over a wide area. A Faraday cage shields electronics from the electric field component of EMP. 7.2. The physics of EMP. What happens? High altitude nuclear EMP, HEMP, produces three components. E1 pulse, 0 to 100 nanoseconds, extremely fast time, destroys semiconductors, microprocessors, and control electronics, not stopped by surge protectors, too low to respond. E2 pulse, similar to lightning strike, surge protectors can handle this component. E3 pulse, slow, DC-like waveform, affects long conductors, power lines, phone lines, pipelines, can destroy transformers by inducing catastrophic currents. A solar CME Carrington type event, primary E3, like, affecting long conductor infrastructure, would destroy most of the power grid, would not directly destroy electronics unless they are connected to grid during the event. 7.2. Faraday cage, design materials effectiveness. A Faraday cage works by distributing an external electric field across its conductive surface with zero field inside. Effectiveness depends on continuity of shielding material, grounding for static/low frequency, not required for EMP, an attenuation depth, skin depth at relevant frequencies. Material: steel ammo can, sealed. Attenuation dB, 40 to 60 dB, high frequency. Ease of build, pre-built, buy ready. Cost, $15 to $30. Notes, very practical, ensure lid gasket is metallic contact. Material, aluminum trash can with lid. Attenuation, 30 to 50 dB. Ease of build, pre-built, cost, low. Notes, line inside with cardboard to prevent device contact with metal. Material, copper mesh, copper screen. Attenuation, 50 to 80 dB. Ease of build, requires fabrication. Cost, medium. Notes, best material, solder at all seams. Material, galvanized steel mesh. Attenuation dB, 40 to 60. Ease of build, moderate fabrication. Cost, low, medium. Notes, opening must be smaller than 1/4 wavelength of highest threat frequency, 5 millimeters for 1 E1. Material, aluminum foil, 5 layers. Attenuation dB, 20 to 40 decibels. Ease of build, very easy. Cost, very low. Notes, wrap device in cardboard first, then multiply foil layers. Seam quality matters most. Material, microwave oven, unplugged. Attenuation dB, 40 to 60 dB. Ease of build, pre-built. Cost, salvage, free. Notes, unplug and keep door closed. Practical for moderate protection. Building an effective EMP Faraday container. The most practical approach for most people. Acquire 30 mm or 50 caliber ammo cans, steel military surplus, or galvanized steel trash cans with lids. Step 1. Inspect lid to body contact. Metal to metal contact must be continuous around entire perimeter. Add adhesive copper tape to gasket area if there are gaps. Step 2. Line interior with cardboard or dry cloth. Electronics must not touch the metal walls. Creates a short circuit that bypasses protection. Step 3. Place items inside. Keep them in their own insulated pouches/bags if possible. Step 4. Seal. For trash cans, wrap the lid to can. Seam in aluminum foil tape after closing. Test closure quality before relying on it. Step 5. Optional. Place your Faraday container inside a larger one for a double protection. Nested cages add to attenuation in series. (7.3) What to store in Faraday protection. Priority highest. Items. Handheld ham/GMRS radios, solar charge controllers, MPPT controllers. Why critical? Communication and power management restored first. Priority highest. Spare vehicle ignition modules. Older carbureted vehicles don't need these. Why critical? Modern vehicles are EMI sensitive. Pre-1980 carbureted cars are naturally EMP resistant. Priority high. Laptop with offline AI loaded. USB drives with data. E-ink readers with book library. Why? Critical. Knowledge access post-event. Priority high. Raspberry Pi units, low-raw boards, small inverters. Why critical? Communication, mesh, and power. Priority medium. Spare solar panels, partially shielded by glass. Store extra charge controllers. Why critical? Power restoration. Priority medium. Medical device spares. Insulin pump parts, hearing aid, handheld GPS. Why critical? Medical navigation. Priority lower. Hand tools, manual items. Why critical? These are not affected by EMP. No protection needed. (7.4) Grounding and lighting protection. Lightning protection. A Faraday cage does not need to be grounded for EMP protection. Grounding is actually irrelevant for E1 protection, and it can be a liability for E3 by providing a coupling path. However, for general EMF, noise reduction, and lightning protection of installed systems, ground all solar components, panels, racking, inverter, chassis, battery enclosure to a single earth ground point. Use 4 AWG or larger copper wire to an 8-foot copper ground rod driven into moist soil. Surge protectors on all AC currents. Type 2 SPD, surge protective device, rated for your system voltage. These stop E2 and lightning-induced surges. Lightning rods. Install on any structure you want to protect. Must bond to buried ground ring. 10-gauge bare copper wire, 18-inch deep around perimeter of structure. Faraday cage for sensitive electronics. Always disconnected from power and antenna when not in use to prevent EMP coupling through conductors. Section 8. Fuels, chemistry, and salvage. 8.1. Fuel storage, ratios, and shelf life. Fuel type, gasoline, 87 to 93 octane. Energy density, 132 mJ per gallon. Shelf life, untreated, 3 to 6 months. Shelf life treated, 12 to 24 months, pre-G or STA. Storage notes. Store in metal containers, no plastic long term. Keep full to reduce condensation. Fuel type, diesel number 2. Energy density, 138 mJ per gallon. Shelf life, untreated, 6 to 12 months. Shelf life treated, 18 to 24 months. Storage notes. Biocide additive prevents algae. Pre-D stabilizer. Fuel type, propane LP. Energy density, 91 mJ per gallon. Shelf life untreated, indefinite, tank limited. Shelf life treated, NA. Storage notes. Store upright, outdoor, away from ignition. 500 gal buried tank preferred for household. Fuel type, ethanol, E100. Energy density, 84 mJ per gallon. Shelf life, untreated. Indefinite if sealed. Shelf life treated, NA. Storage notes, corrosive to many seals, flex fuel or carbureted engines only at high percent. Good cleaning solvent. Fuel type, kerosene, number 1, 135 mJ per gallon. Shelf life untreated, 2 to 5 years. Shelf life treated, 5 to 10. Storage notes, most stable of liquid fuels, heat lamps, jet stoves, wick heaters. Fuel type, wood, dry hardwood. Energy density, 22 mJ per kg. Shelf life untreated, years, if dry. Shelf life treated, not available. Storage notes, 2 cords equal typical winter heat. 1 cord equals 100 cu foot stacked. Fuel type, charcoal hardwood lump. Energy density, 30 mJ per kg. Shelf life, untreated. Indefinite if dry. Shelf life treated, not available. Excellent for cooking, water filtration, metal smelting, blacksmithing. 8.2 Wood gas gasification. A gasifier converts solid biomass, wood, corn cobs, charcoal, into SNI primary CO plus H2, which can power an internal combustion engine. World War II era technology, fully proven. A vehicle running on wood gas gets approximately 1.5 to 2x the wood weight equivalent of gasoline in driving range. Basic gasifier components: hopper, fuel loading, combustion zone 900 to 1200 C, reduction zone, charcoal bed, gas cooling, cyclone separator, tar/particulate removal, fabric filter, fine cleaning, gas mixture at engine intake. Key ratio: air to fuel ratio in the combustion zone is critical. Too much air equals combustion waste energy. Too little equals incomplete gasification, tar. Target 1 to 1.2 stoichiometric. Tar problem. Tar destroys engines. Multiple filter stages required. Wet scrubber, water, then sawdust bed, then fabric filter minimum. Power reduction. Expect 30 to 40% power reduction versus gasoline at same throttle settings. SNI gas is lower energy density fuel. Disclaimer: wood gas danger, carbon monoxide. SNI gas contains 15 to 30% carbon monoxide, colorless, odorless, lethal. Never operate or test a gasifier in an enclosed space. Minimum: run outdoors with CO detector. CO alarms require in many vehicle or structure where gasifier is attached or stored. Symptoms of CO poisoning: headache, dizziness, confusion, often mistaken for fatigue. 8.3 Essential chemical supplies and ratios. Chemical: sodium hypochlorite, bleach, 5 to 8.25%. Primary use: laundry. Emergency uses: water purification, surface disinfection, wound irrigation. Storage: cool, dark, degrades 20% per year. Danger: reactive with ammonia, toxic gas. Chemical: hydrogen peroxide 3%. Primary use: antiseptic. Emergency uses: wound cleaning, mold killing, oxygen bleach substitute. Storage: dark bottle, light degrades it. Danger: stronger concentrations are explosive oxidizers. Chemical: isopropyl alcohol, 70 to 91%. Primary use: surface disinfectant. Emergency uses: disinfection, fuel or alcohol stoves, solvent, fire starter. Storage: sealed container, evaporates. Danger: flammable. Chemical: sodium hydroxide. Primary use: drain cleaner. Emergency uses: biodiesel production, soap making, food processing. Storage: sealed, absorbs moisture from air. Danger: severe burns, handle with protection. Chemical: calcium hypochlorite, pool shock, 65 to 73%. Primary use: pool sanitizer. Emergency uses: water purification, much more concentrated than bleach. Store less. Storage, dry, sealed, fire risk if damp. Danger, strong oxidizer, isolate from organics. Chemical, citric acid. Primary use, food preservation. Emergency use, pH adjustment, cleaning, limescale remover. Storage, indefinite if dry. Danger, mild, very safe. Chemical, potassium permanganate. Primary use, water purification. Emergency uses, water treatment, wound antiseptic, fire starting with glycerin. Storage, dark container. Danger, strong oxidizer, stains everything purple. Calcium hypochlorite dilution. Pool shock is at 68% is 45 times stronger than 5% bleach. To treat 1 liter of water, dissolve 1/4 teaspoon in 1 gallon of water. Make stock solution. Then use 1 part stock to 100 parts water, or 1/16 teaspoon small pinch per gallon of water directly, equals approximately correct concentration. Salvage guide. What to pull from common sources. Sources to salvage. Window AC unit. Useful components: compressor, refrigerant for dehumidifier build, copper coils, fan motor, capacitor. What to look for? Labels: BTU, refrigerant. Type R410A preferred. Priority high. Source to salvage: old vehicle, pre-1980, carbureted. Useful components: alternator, 12 volt, 40 to 80 amp, power source. Lead acid battery, copper wire, fuel drain tank. What to look for? Pre-electronic ignition equals EMP resistance. Save whole vehicle. Priority critical. Sources to salvage. Solar street lights. Useful components: small solar panel, 10 to 15 watts. Lithium-ion battery, basic MPPT controller. What to look for? Common in parking lots. LED driver included. Priority high. Source to salvage. UPS uninterruptible power supply. Useful components: 12 volt sealed AGM batteries, small inverter, battery charger, circuit. What to look for? Office/data centers units have about 5 to 100 amp battery banks. Priority high. Source to salvage. Refrigerator, broken. Useful components: compressor, copper tubing, soft copper for plumbing, fan, insulation, can repurpose. What to look for? Only useful if cause of failure known. Electrical versus compressor. Priority medium. Source to salvage. Electronics, phones/laptops. Useful components: lithium cells, copper wire, magnets. Rare earth from speakers/drivers. Small DC motors. What to look for? Individual 18650 cells from laptop packs. Tests with each multimeter. Priority medium. Source to salvage. HVAC systems. Useful components: large motors. ECM type are efficient 3-phase. Capacitors, copper, wire tubing, fan blades. What to look for? Fan motors, 1/4 to 1 HP common. Useful for water pumping with modification. Priority high. Priority medium, Source to salvage. Ham radio from estate/garage sale. Useful components: complete HF rig may work. Test. Antenna wire dipole. Ferrite cores EMI. Filtering. What to look for? ICOM, Kenwood, Yaesu. Top brands widely repaired. Priority high if radio capable. Section 9, Barter Economy and Community Organization. Individual preparedness has limits. Community resilience is exponentially more powerful. Skills and relationships are the most valuable asset in prolonged crisis. 9.1 High value barter goods. Vices, addictive goods. Tobacco, alcohol, coffee, sugar, caffeine pills. Why valuable? People will trade high value for habit items. Storage. Spirits, indefinite. Tobacco, 2 to 5 years. Sealed. Coffee, 5+ years. Green beans. Category, medical. Item, antibiotics, pain relievers, bandages, feminine hygiene, reading glasses. Why valuable? Irreplaceable, immediately needed. Storage, cool, dark, dry. Most last past expiration. Category, fuel. Gasoline, propane canisters, lighter fluid, butane canisters, matches. Why valuable? Critical for cooking, heating, and vehicles. Storage. See Section 8, Storage Guidance. Category, seeds, open, pollinated. Items, vegetable seeds, non-hybrid varieties. Why valuable? Food, sovereignty, grows years after. Storage, sealed, cool, dark. 5 to 20 year viability. Skills/services. Items, medical care, mechanical work, dental, radio operation, farming, knowledge. Why valuable? Cannot be stored but commands premium barters. Storage, invest in trading now. Training now. Category, hand tools. Items, axes, saws, hand drills, wrenches, knives, files. Why valuable? Function without power. Storage, oil to prevent rust, indefinite lifespan. Category, batteries and lighting. Items, AA, AAA, D cells, USB power banks, LED flashlights, candles. Why valuable? Universally needed, immediately post-grid. Storage, lithium cells, 10 to 20 years shelf life, alkaline, 5 to 7 years. Category, communication. Item, handheld FRS radio, walkie-talkies. Why valuable? Coordination and safety for groups. Storage, keep in Faraday until needed. 9.2 Community roles. Essential skill sets for group survival. Role, medical health care. Critical skills, WFR CERT, nursing skills, herbalism, dental. Minimum group of 20 needs 1 to 2 people. Notes, highest return on training investment. Role, communication/intel. Critical skills, ham radio, mestatic, map reading, threat assessment. Minimum group of 20 needs 1 to 2 people. Notes, information is security. Role, mechanical/electrical. Critical skills, engine repair, solar power systems, welding, plumbing. Minimum group of 20 needs 2 to 3 people. Notes, keep all other systems running. Role, agriculture, food. Critical skills, seed saving, soil knowledge, animal husbandry, food preservation. Minimum group of 20 needs 3 to 5 people. Notes, everyone eats, most critical long term. Role, security/defense. Critical skills, situation awareness, community law, threat deterrence. Minimum group of 20, 3 to 5 people, rotating. Groups, prevention, more important than reaction. Role, construction/shelter. Carpentry, masonry, roofing, water management. Minimum group of 20 needs 2 to 3 people. Long-term habitability is the note. Role, logistics/trade. Critical skills, inventory management, barter negotiation, route knowledge. Minimum group of 20 needs 1 to 2 people. Notes: resource allocation and external relations. Role: childcare education, critical skills, teaching, child supervision, moral maintenance. Minimum group of 20 needs 2 to 3 people. Notes: often overlooked, critical for long-term cohesion. 9.3 Security Operations Principle-Based Framework. Security in a crisis is primarily about deterrence, early warning, and community trust, not the combat. The goal is to never need to use force. Permanent awareness. Perimeter awareness. Know your neighbors. A trusted neighbor is your first early warning system. Community cohesion deters opportunistic threats more than physical barriers. Information asymmetry. Know more about your area than others. Maps, local contacts, alternative routes, water sources, and threat patterns. OPSEC. Don't advertise your supplies. Visible food, fuel, or generator noise attracts attention. Cover windows at night if using lights when neighbors are dark. Tiered access. Not everyone in a community needs to know all storage locations or plans. Information on a need-to-know basis protects against social engineering. Conflict resolution. The vast majority of crisis conflicts are resource disputes. Clearly established fair protocols for resource sharing prevent internal conflicts that is far more damaging than external threats. Section 10. Master Quick Reference Tables. 10.1. The 72-hour bag. Individual minimum. Category: water. Items: water 2 liter minimum, water filter, Sawyer squeeze or life straw. Quantity: 2 liter plus filter. Weight: approximately 2.2 kg. Category: food. Items: emergency ration bars, 360 calories plus jerky/nuts. Quantity: 1 bar plus 1 pound snacks. Weight: 0.8 kg. Category: shelter. Items: emergency bivvy, SOL, plus tarp 8 by 10 feet, plus 550 paracord 50 feet. Quantity: 1 each, 0.7 kg. Category: fire. Bic lighter 3, plus waterproof matches, plus ferro rod, plus tinder, dryer lint. Quantity: multiple. Weight: 0.2 kg. Category: first aid, IFAK, tourniquet, hemostatic gauze, compression bandage, trauma shears, gloves. Quantity: 1 kit. Weight: 0.5. Category: communication. Handheld radio, GMRS, charged battery bank, 200 mAh, whistle. Quantity: 1 each. Weight: 0.6 kg. Category: navigation. Items: paper maps, local/regional, plus compass plus local knowledge. Quantity: maps plus compass, 0.3 kg. Category: tools. Items: fixed blade knife, multi-tool, headlamp, extra batteries, duct tape, zip ties. Quantity: 1 each. Weight: 0.8 kg. Category: documents, ID copies, cash, small bills, medical records, contacts written down. Quantity: waterproof envelope. Weight: 0.1 kg. Total: 6.2 kg, 13.7 pounds. 10.2 Critical ratios and formulas, master reference. Water purification, bleach 5 to 8.2%, clear water 2 drops, cloudy water 4 drops, wait 30 minutes. Water purification, pool shock 68%, stock solution 1/4 teaspoon in 1 gallon. Use 1 to 100 stock to water. ORS, oral rehydration, 1 liter water plus 6 teaspoon sugar plus 0.5 teaspoon salt. Salt cure, meat short term, 2 to 3% salt by weight, 10 to 15 brine solution for submerged cure. Lacto fermentation, 2 to 3% salt by weight of vegetables. Purpose: bleach disinfectant surfaces. 1 tablespoon bleach per gallon water. Power calculation: watts equals volts times amps. Watt hours equals watts times hours. Amp hours equals watts / voltage. Solar sizing: panel wattage equal daily wattage hours over sun hours times 0.75 efficiency factor. Battery bank sizing: lead acid, total amp hours equal watt hours needed over voltage over 0.5. Only use 50% of rated. Biodiesel base ratio: 1 liter oil plus 200 milliliters methanol plus 3.5 to 7 grams sodium hydroxide. Titrate based on oil. CO2 concentration alarm: greater than 100 ppm poor air quality, greater than 500 ppm dangerous, greater than 12.5% explosive. Caloric minimum: 1500 calories a day for adult survival, 2500 calories a day for heavy work. Dehumidifier yield: output drops approximately 50% for every hour, 10% RH drop below 70% RH. Fire triangle: fuel, heat, oxygen equal fire. Remove any one element to extinguish. Faraday mesh opening max: must be less than 1/4 wavelength of the highest frequency thread. E1 equals 300 megahertz equals 25 centimeters. Use less than 1 centimeter for safety margin. 10.3 30-day supply for 4 people. Minimum food store. Food items: white rice, quantity for 30 days, 90 pounds. Kcal contribution: 140,000 calories. Storage container: 5-gallon food grade bucket, O2 absorber, sealed. Food item: beans, pinto / black, quantity for 30 days, 40 pounds, 18 kg. Kcal contribution: 61,000. Storage container: 5-gallon bucket, O2 absorber. Food item: oats, rolled, quantity for 30 days, 30 pounds. Kcal contribution: 53,000. Storage container: 5-gallon bucket, O2 absorber. Food item: cooking oil, quantity for 30 days, 6 gallons. Kcal contribution: 191,000. Storage container: original sealed containers, cool, dark. Food item: sugar, quantity for 30 days, 20 pounds. Kcal contribution: 35,000. Storage container: mylar bag in bucket. Food item: salt, quantity for 30 days, 10 pounds. Kcal contribution: electrolytes, essential. Storage container: any sealed container. Food item: canned protein, tuna / chicken, quantity for 30 days, 120 cans, 6 pounds of protein. Kcal contribution: 24,000. Storage container: original cans, rotate stock. Food item: honey, quantity for 30 days, 8 pounds. Kcal contribution: 11,000 plus medicine. Storage container: original sealed jars. Food item: multivitamins, quantity for 30 days, 120 tablets, one per person per day. Kcal contribution: micronutrient insurance. Storage container: sealed bottle, cool / dark. Total approximate: 515,000 kcal total. Container: 4,300 kcal per person per day. Generous margins applied. This is the end of the document. If there is major grid collapse, with any emergency situation, Please rely on safety first. Any items, ratios, or advice in this video should always be double-checked before carrying any of the tasks or advice through. I hope this was helpful to you. Feel free to download at the end of the video and leave a like and subscribe to the channel. I will be doing series like this as much as I can, where I create guides and lists that you can have for an offline or reference material.